Okay, so far, now the camera's going here. We multiplied these two together. 4 times negative 2. Well, okay. We multiplied this matrix times this matrix, and we got this matrix. And whenever you have the ones like this, the 1, 0, 0, 1, for the 2 by 2, that is called the identity matrix. So we've established that. Then I asked you to take that matrix, 1, 0, 0, 1, and multiply it by 4, 7, 1, 3. What did you get when you did that? Camille? 4, 7, 1, 3. Very good. All right, so what's this analogous to, I guess, just with numbers? I take this matrix times this matrix, I get this matrix. What's this like, what you're doing in the real number system? Multiplying by 1. And 1 is the multiplicative identity, so that's why we call this the identity matrix. Any questions on that? Okay. Now, if you multiply two matrices and the product is the identity matrix, those are called inverse matrices. So now let's just say the identity matrix, the big letter I is used to represent the identity matrix instead of writing out the whole thing every time. So if A, let's say this is matrix A here, and this is matrix B here. If A times B is equal to the identity matrix, then A and B are inverses. And we can write, instead of writing B, we could write B like this. The inverse of A, that power of negative 1. Okay? Any questions on that? Okay. Next thing I want to do with this is work on how to find an inverse matrix. Given a matrix, how do we find the inverse matrix? The first thing I need to do is tell you how to come up with a number called the determinant of a matrix. And all I'm going to tell you now is that the determinant is a useful number associated with a matrix. Okay? The determinant is a useful number associated with a matrix. So, let's start out with, if I have this matrix, I'm going to call it A, and then it's my general matrix, and I've got variables here for each entry, A, B, C, D. If I have that matrix, the determinant of A is equal to A times D minus B times C. So you multiply the diagonals. A times B minus B times C. All good? That is how you find the value of the determinant. So going to use that to find the inverse of A. In order to find the inverse of A, I'm going to take 1 over the determinant of A. I'm going to use it as a scalar. Remember, a scalar is just kind of a number on the outside of the matrix that we're going to multiply the matrix by, kind of distribute it over each cell in the matrix. But what I need you to do for our inverse matrix, I need you to flip the A and the D to D and A, okay? Flip the A and D. And don't flip C and B, but make them the opposites of what they were. So this diagonal, we switch positions. These two, we switch signs. We do not switch their spots, though. Everybody good with that? Now, if you recall, our original matrix that we had was 4, -2, -1, and 1. Is that the original? Is that the very first matrix we looked at in our examples? Okay, I'm going to put this -1 power thing here because I want to find the inverse of it. Okay. Now, I'll put the equals here. But I need the determinant. How do I find it? Ryan?
AD minus BC.
Okay, what are my specific values in this one?
It would be 4 times 1 is equal to 4.
Minus,
-2 times -1.
so that's 4 minus
2.
2. So our determinant is 2. Okay? Now, when I go to find the determinant of this matrix, not the determinant, when I go to find the inverse of this matrix now, I put 1 over 2, 1 over the determinant. And what do I do with the numbers inside the matrix? What do I need to do? Go ahead, Isabel. So put the 1 here and the 4 here. And then what?
And then do positives of 2 and 1.
Leave them where they are? Okay, good. And then if we use a scalar and just make one matrix out of it instead of a scalar times the matrix, we would have 1/2 here. We'd have 1 here. 1/2 times 1 is 1/2 here, and 1/2 of 4 is 2. Is that the second matrix we had? That we multiplied and got 1, 0, 0, 1. All right? Is everybody seeing that okay? So, just a few terms here. We talked about the identity 2 by 2 matrix is this, 1, 0, 0, 1. Inverse matrices, when multiplied, give you the identity matrix. The identity matrix times any matrix will be that matrix, right? And our method for finding a inverse matrix is to figure out the determinant, which we defined here. Take 1 over the determinant as a scalar and multiply it by, do this switcheroo here. Leave those the same but switch their signs. Any questions on that? This part? Yep. Sorry. Thank you. Okay?